right, we are going to get started with the 3-1 notes. And like I mentioned in class, this lesson is about solving systems by graphing. Before we get right into that, though, these first couple of examples are going to be checking to see if a certain point, an x and y point, is the solution to the system. So check to see if the given point is the solution to the system. So, part A. Let's say I have the point 2, 4, and I want to see if 2, 4 is the answer, the solution to this system here. X minus 2y equals negative 6, and 2x plus y equals 8. So like I mentioned in class, the only way for a point to be the solution is that it has to work in both equations. It has to make both equations true. So this is my x and this is my y. So I'm going to plug it into each equation and see how it works out. So x is 2 minus 2 times 4 equals negative 6. Well, that's 2 minus 8, which is negative 6. So that one works. And I can't stop here. I have to make sure that it works for both equations. So now we plug it into the other one. So I'm going to have 2 times 2 plus 4 equals 8. 4 plus 4 equals 8. 8 equals 8. Yes. So we can say, yes, 2, 4 is the solution. All right, let's try another one. B. 3, 2. We have 2x plus 3y equals 12. And 8x minus 6y equals 24. All right, so just like last time, we're going to plug it in. 2 times 3 plus 3 times 2 equals 12. So we get 6 plus 6, and that does indeed equal 12. So that one works out. But again, we have to make sure it works for both. So now we're going to plug it in here. 8 times 3 minus 6 times 2 gives me 24 minus 12, which is 12. So that's a no. So we would say no, 3, 2 is not, if I can spell, not the solution. It's not the solution. All right, let's dive into some examples where we actually do some solving. So, example 2, solve the system by graphing. Solve the system by graphing. So here's our system. X plus y equals 4, and 2y plus 4 equals x. Now, before we can graph it, we need to get both equations in slope-intercept form, y equals mx plus b, so we can graph it. So that's the first thing I'm going to do. I'm going to get both equations into slope-intercept form. So up here, I'm going to subtract x from both sides. which gives me y equals negative x plus 4. And then here, I'm going to subtract 4 from both sides, which gives me 2y equals x minus 4. And I'm not done yet. I still got to get rid of this 2, which actually leaves me with y equals 1/2 x minus 2. And now I'm going to graph these. Okay, so we got both equations in slope-intercept form. Now we're going to graph, and then we look for the point of intersection. So I'm going to graph this equation, and I'm going to graph this equation, and I want to look for where those two lines cross each other. So I'm going to start at 4, go down 1, right 1. And then here, I'm going to start at negative 2, go up 1 over 2, and there, boom. There's my solution. So my solution, my answer is 4, 0. My answer is 4, 0. All right, so that was part A. B. Oh, what am I doing? Sorry. I don't know why I put parentheses there. This is what I want. 2x plus y equals 3. All right, 6x minus 3y equals 3. All right, I would like you to pause the video and try this one on your own. All right, so if you rearrange these equations, you would have gotten y equals negative 2x plus 3. And the second equation is y equals 2x minus 1. And then when you graph them, they intersect at the point 1, 1, and that would be our solution. So remember, that means that if I went back and I plugged in 1 for x and 1 for y, it would work for both equations. Okay. Let's talk about classifying systems. Classifying systems. We have 3 types of systems that either have one solution, no solution, or infinitely many solutions. Okay, so all the systems that we've looked at so far have had one solution. And that just means that we have 2 lines that intersect each other at some point, and there's our solution right there. Nothing crazy about that. Now, what I want you to think about is, what would it look like for a system to have no solution? Well, if our solution is where the two lines cross, then for there to be no solution, that means that the lines are not going to cross, which means that they would be parallel. So if the lines are parallel, that would mean they are a system with no solution. And remember, parallel lines have the same slope. All right, third scenario is that we have infinitely many solutions. So let's say I have this line here. How could I possibly draw another line that's going to hit that purple line infinitely many times? Well, the only way that that's possible is if the two lines are actually the same. So same line. Same line. All right, so let's try some classifying. Example 3. Classify and determine the number of solutions. So A. 2x plus y equals 3, and 9 minus 3y equals 6x. All right, so let's just treat this like we were going to graph them. So get them into slope-intercept form. So I'm going to subtract 2x from both sides, which gives me y equals negative 2x plus 3. Now for my second equation, I'm going to subtract 9 from both sides, which gives me y equals, negative 3y. That's still a negative 3y equals 6x minus 9. And now I'm going to divide everything by negative 3, which gives me y equals negative 2x plus 3. All right, what do we notice about these two equations? Y equals negative 2x plus 3. Y equals negative 2x plus 3. They are the same line, which means we would have infinitely many solutions, which we often write shorthand as IMS, infinitely many solutions. All right, let's try another one. 3x plus y equals 3, and 2 plus y equals negative 3x. And in fact, I would like you to try this one on your own. So you're going to solve both of these for y, and then decide if it's going to be a system with one solution, no solutions, or infinitely many solutions. So go ahead and pause the video and check back when you're done. All right, so when you put these in slope-intercept form, the first one gives you y equals negative 3x plus 3. The second one is going to give you y equals negative 3x plus 2, which means they are parallel. They have the same slope, but they are not the same line, which means that this system would have no solution. Okay, before we start our final example, you're going to need your book, okay? I need you to get your textbook. If you don't have it with you right at the moment, pause the video, get it out of your backpack, whatever, and you're going to open it to page 185. So pause the video, go get your textbook and open it to page 185. I'll see it when you have your textbook. All right, so I am looking on page 185 in the textbook, and I am going to read that little story problem right there for example 4. So example 4 says, Big Dog Snowboard Company charges $15 for equipment rental plus $35 per hour for snowboarding lessons. Half Pipe Snowboards Incorporated charges $40 for equipment rental plus $25 per hour for lessons. For what number of hours is the cost of equipment and lessons the same for each company? Okay, so that means we need to write an equation for each of the different snowboarding companies. So we have Big Dog and we have Half Pipe. All right, so at Big Dog, my total cost, I pay $15 in equipment rental, and that's just a one-time fee. But then I pay 35x, 35 times the number of hours that I'm getting the lessons. Half Pipe, you pay $40 for equipment. However, you only pay $25 per hour. $25 per hour. Now, these are two lines that we know how to graph, and we're going to find where they intersect. And we know they're going to intersect because they have different slopes. They have different slopes. Okay, so this graph, you're going to need to make it kind of tall. I'm going to use quite a few lines here. I'm going to make each line on my paper worth 20, but I'm going to mark every 10. One, two, three, 4. All right. I really like using a ruler when I'm doing these graphs, so that way we can be really accurate when we find the intersection. All right, so for Big Dog, we're going to start at 15. And I'm going to go up 35 over 1. So 15 plus 35 puts me at 50. Plus another 35. 50 plus 35 is 85. Plus another 35 is 120. And then I think I'm going to run out of room here, so we're going to call that good. All right, so that's Big Dog. All right, Half Pipe. I start off paying more, but I pay less per hour. I start at 40, but I'm only paying 25 per hour. So 40 up to 25 is 65. Plus another 25 is 90. 90 plus 25 is 115. So there you go. We've officially crossed the border. Half Pipe. Then we look. Looks like right about there, which is about 2.5 hours and $100. So when you've had 2.5 hours worth of lessons at both places, it's going to cost you $100 at both places. So our answer is 2.5 hours. All right, that is it for lesson 1 and solving systems using the method of graphing. Make sure you check Google Classroom. We're in week 6, believe it or not, week 6. Week 6, assignment 1, to see what else you need to do before I see you later this week.